All right, guys, we are on the last section of this whole entire unit. We're going to talk about parallel and perpendicular lines, their equations, their slopes, and we're going to break this up over 2 days. So today we're going to talk about slopes, mainly just slopes, and how we can use those slopes to determine if lines are parallel or perpendicular. So parallel lines are two lines that never cross. And how we know if lines are parallel. So it's algebraically, so looking at numbers and equations, how do we know if two lines are parallel? Their slopes are equal. They're exactly the same. So they have to be exact. Perpendicular lines are two lines. They do cross. That cross at a 90-degree angle. It's like what you see here. You have that little box. And algebraically, how do we know if they are perpendicular? And this is going to be kind of a big word here. Slopes are opposite reciprocals. So let's talk about what that means. Opposite reciprocals or negative reciprocals. I don't like the word negative because I like the word opposite. So some examples of opposite reciprocals. I think that you guys know what the word equal means. So like, for example, if you have one that has a slope of 3/4, the other would have a slope of 3/4. Opposite reciprocals are a little different. So for example, if you have a slope of 3/4, the opposite reciprocal, opposite means it's going to be the opposite sign. So negative, because this one's positive. And then reciprocal would be you flipping the fraction. So reciprocal means flipped fraction. So you would have -4/3. These are opposite reciprocals. So the opposite reciprocal of 2, so that's positive, so it would be negative. Now the reciprocal, 2 as a fraction is 2/1. So if you were to flip it, it would be 1/2. These would be opposite reciprocals. For this one right here, and this will be the last one we do, the opposite reciprocal, this is negative, so this would be positive, so I don't have to write anything. And then the reciprocal would be to flip it, it would be 8/7. So those are examples of opposite reciprocals. So basically today, what you're going to be doing is either calculating the slope. We're going to start with calculating the slope and comparing them. And we're going to see, are our slopes equal or are they opposite reciprocals? Or maybe they're neither of those. So let's take a look at a couple of examples here. So we are given some points and we need to determine if these lines are parallel, perpendicular, or neither. So to do that, we first need to find the slopes. So let's find the slope between point A and point B here. So for AB, we have these 2 points and we need to find the slope between them. For me, when I find the slope, I stack my points. So we have -2, 3, and 2, 6. So to go from 3 to 6, I go up 3. To go from -2 to 2, I go up 4. So to write my slope, you write it right over left. So the slope would be 3/4. You're going to have to identify slopes today. So you're going to need to make sure you know what that is. Then I now need to also find the slope of CD. So I take my points and I stack them. -1, 0, 3, 3. So to go from 0 to 3, I go up 3. To go from -1 to 3, I go up 4. So then to write my slope, you write it right over left, 3/4. Once you've written your slopes, now you compare them. 3/4 and 3/4, they're exactly the same. So these two lines, I would write my answer, or my answer would be parallel. So each one of these is technically going to be 3 problems in one. 1 for the slope, 2 for the slope, 1 for the parallel, perpendicular, or neither. So let's take a look at another one. If we take a look at number 2 here, and I think this might be the only other example I do. I think you guys can handle this. So if we have AB, I'm going to stack my points. I have 0, 2, 5, 4. To go from 2 to 4, I go up 2. To go from 0 to 5, I go up 5. So to write my slope, it's 2 over 5. And then I'm going to do the same thing for CD. I have 1, 8, 3, 3. So to go from 8 to 3, I go down 5. To go from 1 to 3, I go up 2. So my slope, again, right over left, -5 over 2. And then you compare them. If you look at your slopes, they're definitely not equal, but they are opposite signs and they're flipped. So this would be perpendicular. So that's an example of a parallel and an example of a perpendicular. Now, neithers will pop up here and there. Neithers are going to be kind of obvious because they're going to not look like anything. So let's move on to the equations. Okay, when you're given equations, you kind of do the same thing. Sometimes they're a little bit easier, especially if one or both of them are written in slope-intercept form. So when you're given equations, I'm actually going to draw lines because these are the three that we're going to do. I'm going to draw lines between them so that I know that I technically have to figure out the slope of this equation, the slope of this equation, and then I have my answer. So you are still doing what we did with just the points, except for now you're not having to find the slope as it's not as much work. So for number 9 here, this example, when your equation, and you have to have your if you're given an equation, it has to be in slope-intercept form. So it has to be in y equals form, or y has to be by itself. If it's not, that's the very first thing that you need to do. Once it's in slope-intercept form, it's kind of easy to identify what your slope is. So your slope is always the number that's in front of x if it's in slope-intercept form. So in this case, my slope is 7. This case, my slope is 7. And because they are equal slopes, these lines would be parallel. That was kind of an easy one for you because it was already in slope-intercept form. Let's take a look at 11 here. Both of these are also already in slope-intercept form. This line has a slope of -1/3. This line has a slope of 1/3. So they're not exactly the same, so they're not parallel. They are opposite signs, but they are not reciprocals, meaning that they're not flipped from each other. So this would be an example of a neither, because they're not reciprocals, but they're also not equal. So that would be an example of neither. For the last example that we're going to chat about, I want to show you one where you do have to do a little bit of transforming here. So for this one right here, this line or this equation is already in slope-intercept form. So this is going to be the slope. So this one has a slope of -1/5, which is great. We don't have to do any work there. This one, we got a little bit of work to do. So you have to get this into slope-intercept form first. So to do that, we need to get y by itself. So to get y by itself, we are going to subtract 5x from both sides. -y equals -5x plus 4. You can't leave this as -y. This is the same thing as -1. So now we're going to divide everything by -1. And we get y equals negative divided by negative is a positive. 5 divided by 1 is 5x. And then +4 divided by -1 is -4. Once you have it solved, you can figure out what the slope is. And this one has a slope of 5. So I have a slope of 5 here. I have a slope of -1/5 here. So when you are determining whether they are parallel, perpendicular, or neither, they are definitely not parallel because they're not the same. Perpendicular, though, let's take a look. So they are opposite signs. You have to ask yourself, though, are they reciprocals? So -1/5, and this is 5/1. So they are flipped from each other. So these are perpendicular. So that's an example of parallel, perpendicular, and neither. If this still is confusing, show up to the Google Meet and I will go over additional examples.